today's session we will be discussing about cylindrical coordinate system and the transformation between Cartesian and cylindrical coordinate system. So let us understand how to define cylindrical coordinate points. So the radius of the cylinder is mentioned as rho, and the angle that radial distance made with the x-axis is phi, and height of the cylinder is z. So obviously the radius of the cylinder varies from 0 to infinity. The azimuth angle varies from 0 to 2 pi, complete 360 degree, and my height of the cylinder can vary from minus infinity to plus infinity. If I want to write a vector in cylindrical coordinate, I should write a component of a vector along this radial direction, that is a rho into the corresponding unit vector a rho cap, plus component of phi along this direction, so a phi into a phi cap plus a z into a z cap. So if I want to find a magnitude, I have to just take the root of sum of the squares of the components along each of the axes. So we already know, we have written rho phi z in a cyclical order. We already know the dot product of two unit vectors, dot product of same two unit vectors, okay, will give me the result 1. Whereas dot product of different unit vectors, if I take in a sequence, it will result in 0. Whereas the cross product of two consecutive vectors will give me the third unit vector. For example, let us see the first one, a rho cross a phi will give me a z cap. Whereas a phi into a rho cap will give me minus a z cap. The direction reverse means the negative sign comes into the picture. Similarly, we can write it for other two sets, it is a rho into a z, similarly a z into a rho. Now let us understand how to write the differential elements, length element, differential surface, and volume element. So we have considered initially the radius of the cylinder rho, right? Now we are going to just take the incremental radial element, that is d rho along the rho axis, and d phi, it depends on the radius. So we are taking arc length as rho into d phi, and for z it is dz. So I can write in a vector from dl cap is equal to d rho into a rho cap plus rho d phi into a phi cap plus dz into az cap. If I want to find the differential surface area, there are three different surfaces. Okay, if I take this unit normal vector a rho, and if I want to find the differential surface area, so it is just a product of rho d phi into dz. Okay, and it is multiplied with the corresponding unit vector. If I want to find ds phi cap, that is the differential surface area that is perpendicular to a rho cap, it is just a product of d rho into dz into a rho cap. Similarly here, rho d phi into az cap for ds ez vector. So if you want to find the volume element, it is going to be just the product of all the differential elements that we have taken into consideration. So taking rho outside, rho d phi dz is my volume in the cylindrical coordinates. Now let us understand how to convert a given point in Cartesian coordinate to cylindrical as well as the reverse. So to do that, we are considering a point in x, y, z coordinates, and that is equal to the cylindrical coordinates rho, phi, and z. So we can write, we can take this particular triangle, right angle triangle, and we can find x and y in terms of rho and psi. So by taking cos psi, we get adjacent by hypotenuse, that is x by rho. Sin psi, it is opposite by hypotenuse, is the opposite to this angle by hypotenuse, y by rho. From this I can write x is equal to rho cos phi, y equal to rho sin phi. Is it remains the same. Whereas if I want to find the angle, I have to take tan phi, which is nothing but sin phi by cos phi. So y by rho divided by x by rho get cancelled. My result will be y by x. So phi equal to tan inverse of y by x. Whereas if I want to take find the value of rho, the radius of the cylinder, it is going to be just the root of x square plus y square by applying the Pythagoras theorem. Okay, so these are the relation between the coordinate points. Now let us find the relation between the unit vectors. If suppose ax, ay, az cap unit vectors are given in Cartesian, how should I convert to cylindrical unit vectors? So for finding that, let us take the differential length element in Cartesian, that is dx into ax cap plus dy into ay cap plus dz into az cap. So to find the first unit vector, that is a rho cap, what we are doing, we are taking this differential length element in Cartesian and differentiating with respect to the rho, okay, whatever unit vector we are considering. So we know the value of x, y and z from this above expression. So we have to just differentiate this x with respect to rho. What will be my answer? Cos psi will be there. The rho get differentiated to 1. Whereas if I differentiate this y expression with respect to rho, I will get sin phi only. Similarly, differentiation of this component dz. So again I will get, there is no rho component, right? Dz by d rho is substituting the above differentiation values that we got here. We will get a rho cap is equal to, instead of dx by d rho, we will write cos phi ax cap plus, for this term it is sin phi ay cap. Since the z component is 0, we are neglecting it. Next we can find the next unit vector, that is a psi cap. So for that we have to take the differential element in Cartesian coordinate, the same one, but we have to differentiate with respect to rho d phi. In this case, apart from the unit vector that we are considering along the phi direction, other two coordinates rho and z are constant. Differentiation of that will be equal to 0. So taking that x rho and x, y and z, that expression that we got in previous slide, we are just differentiating x with respect to psi. So if we differentiate and already rho is getting cancelled, we get cross differentiation of cos phi is minus sin phi. Whereas here dy by rho d psi, the differentiation will result in cos phi only. But here, since there is no psi term, this component will be 0. Substituting all in the above expression, we get the expression for a psi cap, that is minus sin phi ax cap plus cos phi ay cap. So to find the third unit vector, that is az cap, we have to differentiate dl, this Cartesian coordinate differential length element divided by dx. So in that case, other two coordinates rho and phi will be constant and differentiation of them will be 0. So taking x rho cos phi, if we differentiate with respect to z, it is 0 because there is no z term. Similarly for y also there is no z term, so differentiation of y with respect to z turns out to be 0. But here there is a z term, so differentiation with respect to z I will get 1. So if I substitute these values in this above expression, the first two terms get cancelled and only this component will remain. Only this component will remain. These two get cancelled and only this component I will get it, that is az is equal to az cap. Now we have written all the unit vector equation a rho, a psi, az as a matrix form. So the values are written row by row, and if I this is the equation this is a transformation I need when I was having the Cartesian unit vectors in my hand. If suppose I have the cylindrical coordinate unit vectors in my hand and I want to find the Cartesian coordinate unit vectors, I have to just take the inverse of this particular 3×3 matrix. But here we can see the inverse is just going to be just transpose. First row converted to first column, second row converted to second column, third row converted to third column. And we have seen till now how to convert a point, how to convert a unit vector. Now we have to convert the components along each direction. If suppose I was given ax, a by az, okay, I want to find a rho, a phi, az, what should I do? I already found the unit vector, right, a rho. I have to multiply with ax to get this first component term. So that if I multiply a rho vector with ax vector, what is my result? So here ax dot ax will come, that will be equal to 1, but ay dot ax is 0. So this term get cancelled and I will get only cos phi as a first term. Similarly, I have to multiply this complete a rho vector equation by, first we have multiplied by ax cap, right, second by second column by ay cap, completely second column. If I multiply, I will get only that component term, sin phi. Similarly, a rho, if it is dot producted with az cap, I will get 0 because there is no az term. So as if you compare these two expressions, whether it is a unit vector or a component along each of the axes in the cylindrical, my matrix remains the same. Okay, similarly in the other end of transformation. I hope this video is useful. Thank you everyone. Let's meet